There's some concepts I'm going to discuss around things like neural networks, which may not be immediately familiar to a food safety professional, but once I show you what it means, I think you'll get it. So let's press on to a little bit of an introduction. So first thing I want to talk about is myself, of course. So very quickly, my background is in food safety consultancy. I've been doing Hasset here in the UK and wider for about 30 years now. And about 22 years ago, I graduated in a postgraduate degree as a software technologist. And the purpose of that was to write some software for Hasset, which I completed in 2000. And ever since then, I've kind of been, I don't know if obsessed is the correct word, but certainly heavily involved in software development and project management, innovation, and so on. It's really been my life's work, and that's what you're about to see today. So everything you're going to see today is the result of all of these years of experience and little successes along the way and so on. We're a relatively small company, got about 10 staff in total, and we work with various independent consultants, particularly in the US and Canada. So a little bit about where we've kind of come from. So the company was started actually as an IP, intellectual property container, in 2010 while I was doing some other roles as an employee. And in 2015, I kind of managed to break free from all that being employed by someone stuff and decided to really focus in on the next generation of food safety systems, which is what hopefully you're about to see. We got our first customer in 2016, who is a major cake manufacturer here in the UK, still with us today. And shortly after that, we began getting other customers, of course. We launched the FSVP, Foreign Supplier Verification Program support for US importers in 2017. And we've been operating in that business since then, which accounts for about half of our revenue, actually. So we do a lot of work in the US and a bit in Canada. We like to do more in Canada. So if you want to work with us, let me know. Global Import Agent for that FSVP side of things is a new business division we launched in 2019. 2020, we launched AI Scan. You're going to see some of that today. And now we're about to launch what we call HVT, HACCP, VACCP, and TACCP. And you're going to see a good bit of that today as well. Just some of the logos of the companies we work with. Weetabix are the UK's largest cereal producers to both the UK and the export worldwide. Park Cakes is UK's largest retail branded cake manufacturer. They were our first customer for 3i Verify. And more recently, we landed the business with Iceland Manufacturing, who are a major frozen foods retailer here in the UK. But in a nutshell, the problem we focus on is this. Any food organisation is generally dealing in silos. So you've got supply chain, you've got quality, technical, production, management, engineer. They've all got different systems. None of the systems talk to each other, and therefore there's different versions of information, documents, spreadsheets flying all over the place. What we want to do is to do this. We want to join them all up with a common system which allows everyone to be talking the same language, using the same data, and making sure it's up to date and accurate. So that's the kind of starting point, at least, for having a good digital system. But we want to go beyond that, and that's what we're really going to talk about today. We favour what we call an integrated approach, which means that for all of the different standards or areas of standards which might be present in, for example, GFSI standards like BRCGS, SQF, and so on, we want to try and bring everything together into one place. So the main problem we're trying to manage within food is risk. We're trying to manage risk. So what does that mean? Well, the ISO standard on risk, ISO 31000 2018, defines risk as the effect of uncertainty on business objectives, and this can be both positive or negative, although mostly risk is associated with negative consequences. The key points here are, what are our business objectives? Well, in food safety, it's about legality, safety, and quality. And then it's about authenticity. And number 5 and 6 on the list are really about the commercial aspects of the businesses. The problem that the industry has in managing risk is with tools and resources. There are lots of siloed and generic tools that do one specific thing. So FERA with Horizon Scan might be looking individual elements of data and trying to make sense of that. SGS DigiComply, same thing. Discernus. We've got one of the architects of Discernus on the call today, Stephen Squarey. So he'll know what I'm talking about. There's a lot of benefits on focusing on one problem. However, food safety is not one problem. It's a problem which is affected by many different factors. So there's information in different countries, be that the UK, Ireland, Canada, Europe, Australia, New Zealand, and of course the United States. They all trade with each other, and therefore we need to be understanding what kind of surveillance they're doing, what kind of food alerts are happening, what kind of hazards are occurring, etc. And then, of course, we've got a plethora of consultants out there who, again, are specialising in certain areas. So the issue here is where do we start when we try and join all of this information up? Then we need to consider the different issues that the technical and quality manager has within the food industry. I don't know how many technical and quality managers are on the call here today, but I do know that most technical and quality managers don't have enough time. They've got too much to do, and they don't have the tools to do the work. And this is a very common problem that even in 2022 is still a huge issue. They're under-resourced and they don't particularly have the right tools. So how do we start to solve this problem? Well, in 2019, what we started to do as a business, we looked at all of the data sources, particularly food recalls and surveillance at the borders of countries, FDA, UK, and so on. And we started to say, well, if HACCP and food safety is really about identifying known and reasonably foreseeable hazards, then what are the hazards, right? We all know the basics: salmonella in poultry, listeria in soft cheese, and so on and so on. It's standard food safety learning. But new things happen, right? So, you know, we've had various things happen with like E. coli and romaine in the USA, massive issue, not seen before it happened in a big way. We also had E. coli and cantaloupe in Europe. We had problems like horse meat in Europe in 2011, melamine, 2007, I think, melamine pet food and baby food. So things do happen which are outside the norm and that are not easy to predict. So what we wanted to do was to look at the data and see if we could train AI to tell us things about that. So we're going to look at some of that in a moment. What we came up with was this kind of concept, our latest project, Hasset, VASSP, TASSP, HVT we call it. And it is that by assessing or learning from all of the hazards and things which go wrong in the food supply chain on using information and data from food safety recalls, allergen recalls, certification issues, import refusals, and so on. So this is data points in the supply chain, and then joining that up with the HACCP, VASSP, and TASSP information, or intentional adulteration and food fraud and preventive controls, whichever terminology you want to use, doesn't matter. In these settings, people within a food organization are analyzing their own either internal or supply chain issues in order to assess risk. And if you join that up with raw materials as well, the information which is going on in the supply chain, then the question is, can we create a better food safety system? And that's the problem that we believe we made a good bit of progress on. But the other point about risk is that risk modeling is a lot more than just greens and reds. And you're going to see some greens and reds and matrices today. I'm going to show you some of that. But there are other factors here. How long ago did things happen? How frequently do things happen? What is the actual impact of things? So, you know, it's not always just about a two-dimensional matrix. So this is a model, if you like, for what we've created here, whereby we've taken all these data sources, which includes internal data sources from within a food business and its supply chain, and then we do some AI processing in around that. There's a lot of logic as well, and there's human intervention, but the AI, what that does is it can process large amounts of data much more effectively and accurately than a human can in many cases, not all, but in many cases. And we feed this in to identify hazards, identify companies, in other words, companies in our supply chain, and the categories of food products. And then we can feed all of that into a risk approach which assesses impact. It's configurable, and then we can take action to correct some of those things. In addition, we can use that to feed into raw material risk assessments, HACCP, VACCP, and also the TACCP intentional adulteration side of things. Regulation is increasingly, not just regulation, but the GFSI standards are increasingly looking at all four of these things being in place and being robust in any food business. This is a screenshot of our back-end management system where the data gets gathered. And you'll see here, for example, this data source here is RASIF, the Rapid Alert System for Food and Feed in Europe. AI has that, or we've used logic to identify the product, the problem. We've classified the hazard, and then we've got a hazard keyword list. And using this data, we can then build up a neural network, or neural map, if you like, which we can use in AI to identify unusual trends, the incidents, what we call anomaly detection, which I'll talk about in a short while. So we then feed all of that into a configurable risk model, which I mentioned earlier on, where you can score how many things are happening. If we had 6 safety alerts in the last 5 years, then there might be a score of 2 for this. And then we move that on to other things like risk event weightings and then forgiveness factors and so on, because these are the maybe more advanced ways of looking at risk and trying to understand how we are affected or impacted by risk. What that results in is a heat map like this. So this is all built by AI. So we've gathered data, we've processed the data. And if you can imagine, this would be the list of your suppliers. And this is the risk rating based on the number of safety events, when they occurred, what kind of events they were. And so it can calculate these numbers according to your configuration, and it's individual for each customer. So we set that up with you. And that means then that you can work out an overall risk score for each supplier. So again, drilling down into each of these suppliers allows us to build up a profile, who they are, where they are, a breakdown of their risk, monitoring their certification, and then looking at any regulatory issues they've had and so on. And if we drill into some of those, this is the kind of thing we can see. And everything in here links back to the original data source, so you can verify and validate all of that, etc. What we also do then is we can look at the hazards which are occurring, and we can run what's called anomaly detection. I'm not going to get into that right now, but here you can see, in fact, in 2019, I can tell you what this is. This was a massive E. coli 0157 recall, which happened in Canada, actually, between October and November 2019. This shows us how the anomaly would throw something unusual. Whereas if you just go on based on the count of alerts that are happening, yeah, you can see there's a bump here and here, but it's not really showing you the full extent. So anomaly detection, which is something we developed, can really help highlight these kinds of things from different data sources. Okay, so I'm going to show you a real example. There's some additional reports and so on you can get to analyze things, but this is the real automated knowledge building, AI-driven hazard linking, which takes place. This example is acrylamide. You can see here how this works and feeds into the software in a moment. It's got a hazard master type of chemical, and it's a contaminant, and it applies to processing operations of baking, broiler, browner, fryer, microwave. So using that information, if we know that baking operation, and we've got a particular type of product, we know that there might be a hazard of acrylamide. We also know that that could be caused by either a product rich in asparagine and reducing sugar, or because the thermal process is too hot. And then we've got a number of controls. And notice that one possible cause here for a hazard can have more than one control. And also notice that that control, same control, can be used for different possible cause hazard combinations. And so when I talk about a neural network or a neural map, that's what I'm really talking about, is the relationships between pieces of information that all come from AI scan, but not just the AI scan side of things, gathering data, but from the people who are doing hazard analysis and raw material risk assessment and so on in their food safety systems. So all of this gets automatically populated and processed by AI in order to build up an accurate map of known and reasonably foreseeable food safety hazards, not just food safety hazards, but intentional adulteration, food fraud, and can be applied to other areas as well. So we're going to look at this in a moment. This is a raw material risk assessment heat map, and all of this uses this neural network to do this. We're also going to look at this. This is an integrated HACCP, VACCP, and TACCP system. We've not launched this yet. We've got a few select customers using it, but this will assess all three at the same time. In fact, it'll also bring in raw material risk assessments into that. So I'm going to ditch the screenshots. You'll get a copy of this presentation later after the event so that you can call some of the things that I'm going through here. But I just want to jump over now to show you a few things. So let's go look at the control panel first. I want to just take you through a few points. This is not publicly available, but it will give you an idea of how we do the back-end data processing. So we've got a massive database of companies which are picked up through our AI scanning of data out there. And many of these come from the global food alerts, which we pick up. So global food alerts, if we look in here, for example, if I wanted to see data from, let's go for Canada, then in here, there's a bunch of alerts. There's 19th of August was the last ones. You guys will probably be familiar with some of these. Each one of these links back to the actual alert itself. And you'll see here, in this particular case, out of that alert, we identified using AI, these are the products, this is the brand, this is the problem, and this is the alert it is. And there's the hazard types, which feeds into the neural map. And that all goes back to this, is where we got the data. So our system is looking for these elements, but we work on trusted data sources. So generally from regulators or from people or sources that are usually the first reporter and they have got some kind of authority. So that's the first point. We get these global food alerts and they come from all different sources. Here's the FDA. So there's all the kind of FDA side of things. 23rd of August, a few days back. Salmonella, also RASIF. So here's all the European stuff. European RASIF do not identify companies, but we can still get product names, what the problem is, and so on, and their keywords. So that's the starting point. That information then eventually, after cleaning and processing and so on, gets fed into our hazard linking tool. And in here, in fact, here's the acrylamide example we were looking at a moment ago. So there's the hazard there, and this is all. If I want to add a new control for this, we can just add the control. We can select from an existing database and so on and so on. But the AI tool also will be able to do that based on what people are entering into their hazard analysis and risk assessments. And you'll see some of that in a moment. So that's the kind of starting point of the fact that we've got data, which is not only coming from these global food alerts, but it's going to be added by users of our system. So to illustrate that, let's do some raw material risk assessments. 3iVerify will handle the full GFSI certification standard in terms of supplier raw material approvals, finished product specifications, audits, document management, corrective actions, product traceability, the whole thing. But we're going to focus in on food safety plan side of things. So any good food safety plan starts with a raw material risk assessment. And in here, what we typically want to do is we want to know what risks are with the manufacturer. We also want to know about allergen, chemical, microphysical, process, radiological, and adulteration. And we also want to know about food fraud. So that's what this does. If I just pick one of these as an example, this is the name of the material. This is the name of the supplier. And sometimes you will have an example where there's a third-party manufacturer. So that's who we want to risk assess in that particular case. So let me just do, I'll pick this one as a random example. I want to do an assessment on that particular manufacturer, then we've got a set of criteria loaded into the system, which you can set up yourself in the admin area here. But here you'll see an assessor, and we've got an approver and a whole audit trail, and there's a history in here as well for previous assessments. So you can carry out these assessments anytime. Now, if I wanted to create a new one right now, this is the kind of thing I'll do. What you're going to notice is that the criteria are all here. And when you pick something, it's going to score it. And above here, associated with this risk assessment, you've got a scoring criteria. So if it's less than 11, you're saying low risk, 11 to 25, medium, and then more than 25, they're going to be high risk. So in each case, you can put in some justification. I'm not going to type stuff out. This is not a full-on demo here. I'm just trying to give you a flavour. And upload a document in there if you want. The approver can then read all of that. and run the scoring, and we get a number come out the other end of all of this, which gives us the most up-to-date risk rating for that particular supplier. So I'm just going to do the assessment on this, put my password in. Once I've assessed it, it goes for approval, but because I'm also set as an approver, I will be able to approve it. So it goes for approval now. The assessment itself gets locked out. The approver gets to see it. I'm an approver also, so I can go look at these documents, run through this, make any comments, and just go ahead and approve it, put in whatever comments I'm going to make here, and then run the approval. So the key thing about this is that we've got control over how and when we do these assessments. Put my password in there. That then gets locked out, so we can't change this now. That is our record, and it also gets added into the history of the assessment on that particular manufacturer. So that's how we do that. All of the scoring criteria, the areas of assessment are all configurable, as are the ranges that you would do these manufacturer assessments on. Now, the important issue I'm trying to lead you to here is that this data then should be able to feed through into the Hasset, VASSET, and so on. So in this case now, I'm going to do an allergen risk assessment on this material. This one is risk matrix based, with the scoring up here, the scoring range here, and what we call the direction of significance. So in other words, any score that comes out less than 12, we're going to deem to be a significant risk, and therefore we're going to need a control in place for that, for example. So down here, we're going to add some hazard risks. Now, this is where the neural network of hazards comes into play, because these all come from there. So you can search this, you can scroll through it, you can find out what, whatever. But the key thing is what we're doing is we're defining properly homogenized ontology, I think they call it, way of naming things and getting things to a point where people can use them consistently. If your hazard doesn't exist, you can add it here, and it will add it into the neural network and process it for quality and so on. So at this point then, where we are doing a risk assessment, kind of similar to before, the matrix itself is defined and definable by the user here, and we get a score that comes out the other end. And then here, what we're doing is we're pulling in the control from that neural network for that particular hazard and possible cause. Again, we run through an approval process and so on and so on. So I won't spend too much more time on this. All of these allergens, chemical, physical, micro, all the way through to adulteration, for example. Maybe worth a look at adulteration. So again, we've got some adulteration hazards in there. That grows with use as well. Therefore, it's almost like crowdsourcing some of this through the industry itself, because together we know more. Food fraud is a bit different. Food fraud has its own criteria set up in the system. And in this particular case, what we're going to see is we've got different areas of food fraud we want to look at. And again, all definable. So supply chain, there's a bunch of questions we might have in here. They're all scored. I think you're sort of getting the idea by now. So we've got the scoring, we've got the score criteria. All of this then feeds back into the overall food fraud assessment. And what we can do is we can set the scope on these to say, well, this applies to all ingredients of a certain type, or all suppliers of a certain type, or whatever. All of this data then ends up in the neural network map, and it also ends up being available in your Hasset Plan. So looking at the Hasset Plan, I've got a test one in here ready to go. If I just open this one, what you'll see is this is the, how we create the process flow diagram, for example. And might as well just do this one. I'll just jump into the chilled storage. So down here, you may recall I mentioned the different operation types. So if I look for chilled storage in here, we've got storage, refrigerated, chilled, and frozen storage. And then in here, I can now start running through my hazard analysis. Now, up here is where I'm going to put in the products. Now, what the system now does is going to pull in the recipe for these products. It's going to look at the raw materials for those products, and then is going to add them into the raw material risk list over here, so that I can look for potential inherent hazards that I need to take account of in my process. So this is us really starting to bring together in an integrated way all of the information from the raw material assessment, supply chain, the neural network map, and so on. So first point, raw materials. Next point, process hazards. Again, from that neural network map, we can pick out the particular hazards that we want to assess in here and just add them. If they're not there, we can add our own. Again, goes into that neural network map and gets processed for quality and so on, so that we can build a high quality knowledge base of these things. Similarly, down here, you've got adulteration of gradients. We've got intentional adulteration. And then down here, you have the food fraud side of things. So once we've got our accepted hazards, we then move on to controls. Once we're in here, the raw material risks have already got their controls, so they're kind of not hidden, but they're shown up front. Here are the new ones. Sanitation program, I want that, so I'm adding that in. Down here, I've got this other one I added in, adulteration, so store ingredients in a secured location. Job done there. And then on food fraud, I've got fraudulent supplier, so definitely a supplier control or a food fraud Hasset program, whatever it is. Again, all of this coming from that neural map. So then we go to risk. So the raw materials have already been risk assessed, so we're mainly interested in process, intentional adulteration and food fraud at this point. And here we've got a configurable matrix which is being used, and that can be set according to the different type. The justification goes in here, and then we go down and we assess, for example, the intentional adulteration there. And again, move on from there. Food fraud, that one's been done, so pick this one. And again, you put your justification in. And then when we're done, we move on to CCP. So CCP, we're only applying to the process hazards. So in this particular case, this one has not been done. You can see a CCP has been identified here, but not here. And these two are PRPs or CGMP, depending on the terminology you're using. So in this particular one, for the example, I'm going to make this a CCP so you can see how this works. This is a Codex Alimentarius decision tree, but we can use any decision tree in here. So if we said that control measures are in place and we said the step, and I know it's not, this is not really a CCP, but I'm going to make it like it is, then we save that, makes it a CCP. Anything that's a PRP or a CGMP, you can then select from the list, you can search this, what the PRPs are that are required for managing that risk. Same thing for intentional adulteration. So you'll see here, like I think food defence is the one we've got. We've got food defence there, staff training, whatever it is, and the same idea for food fraud. So the advantage of this is that you're getting a holistic view of all the things that could go wrong, both in your supply chain through the raw material risk assessment and at any stage in your process through an integrated approach to Hasset, Hasset and TASSEP. So let's go to management. Once you get through the management side, we're much more interested in the CCPs at this point. So here, again, coming from that neural network map that we're adding to, can define your critical limits, what your monitoring is, what the corrective action is. And you'll notice how accurate things are here in terms of the information. So it's really speeding things up. And down here, how often are we doing this? Well, if it's chilled storage, maybe it's going to be whatever, daily. Manager, and in here Hasset team. And then we're on to validation and verification. And again, you've got here cleaning process validation, and maybe that's like every day, and so on and so on. I think you get the idea here. So hopefully this gives a good flavor of how we can create an integrated AI powered, and we call it powered because it's a hybrid. It's about using AI and data and the knowledge and experience of people, real people, to be able to create an automated food safety system. There's a lot more at the back of this with monitoring and alerts and all sorts of other things. But based on the time and to give some time for questions and so on, I think I'll stop at that point. We'll put the camera on, and if you can put your camera on as well if you wish, and then I can answer any questions. Hi, Stephen, go ahead.
Hi, James. I've got a couple of questions, but let me start with this one. Have you run a comparison between an existing Hasset plan for a food company and the Hasset plan that would be generated by your system?
We are in the process of doing that right now with a number of different customers who are taking, they're basically taking what they did already with their Hasset that needs reviewed, and they are effectively using the system to review all of that in the light of kind of a new integrated type of approach, because the vast majority of Hasset plans that are out there tend to get reviewed once a year, if that, and they don't really, most of the Hasset plans I've seen really don't have very good validation and verification programs in place, and they certainly don't take account of things like intentional adulteration and food fraud. Those tend to be separate people doing it differently. So it's kind of still work in progress on that one, Stephen. But our goal here is to enable not only this whole integrated approach, but our goal is to enable the production of the food safety plan and system to be able to be implemented in I think something like 75% less time is what we're aiming for. And so that is still a piece of validation we need to do in this project. We're due to finish the whole project at the end of November, but we've made a lot of progress already.
Okay, well then a somewhat related question is, what's the, and you may not have an answer to this yet because your system is clearly relatively new. I'm curious as to what you project as the length of time that it will take to onboard a typical food company. Say it's a company that's doing $100 million worth of business a year. How long does it take before they're able to experience the benefits of your system?
Well, I mean, I think it's a great question, and I think you're right. I won't be able to answer that one right now, but based on previous experience, I can tell you a funny story right now. Actually, on this one, it's not the $100 million company, but I mentioned earlier about my previous Hasset Now software that's 22 years old. We had a very basic concept of this in there in terms of a knowledge base. And this customer who just came on board with us, who's now bought into this and he's using it, he's actually a sheep farmer running a farm shop. And he had originally purchased our Hasset Now software some years ago, 10 years ago or something. And he'd recently received a visit from the local environmental health officer to say, hey, we want to look at your Hasset plan. And he hadn't looked at it in years. So the EHO, or the environmental health officer, realized that he hadn't been keeping it up to date and told him he's got 28 days to get it fixed. So he contacted me and I said, hey, we don't do that software anymore, but we've got this, but it's not really ready yet. This was about a month ago, but you're welcome to give it a try. So this guy's a sheep farmer, and he got all of his products, so sausages, burgers, his goods inwards, everything all done and dusted in terms of the plan. He got all that done in probably about 6 hours. So I think it's an indication of the fact that once you get into using existing knowledge and you're not having to think it all up for yourself, firstly, it takes a lot of work out of things, but because this is based on real data, not only that we're getting in the supply chain, but that other people that are experienced and expert are inputting into the system, and we're making all those connections. So it's early days yet.
Okay, thank you.
Thank you for that, Stephen. Any other questions? Okay, so I think if everyone's happy with that, I will send a recording of the meeting to the organisers, and that can be distributed out to everyone. If anyone wants to reach out to me, please do get in touch. Okay, well, thank you very much, guys. Have a great day.